Everyone, welcome to our presentation. Our topic is building a trust ecosystem for remote inspection technologies in ship hull inspections. Our article contributes to the need of trust in robotic and autonomous systems, which are shortly written as RAS. Our article is related to a broad variety of linked technologies known as remote inspection technologies working on land, in the air, and underwater, which are covered by robotic and autonomous systems generated from the artificial intelligence. This is our table of content. Firstly, we will be presenting the introduction of our topic, and secondly, the evaluation of pros and cons for both legal and ethical framework. Thirdly, it is explaining the legal and ethical considerations. And fourth one is evaluation of emerging technologies based on our course material. And last one is analysis of the legal and ethical consideration. And my name is Alicia, and I will be presenting the introduction of our topic. So let's first understand what is remote inspection technology. It is a technology installed on remote inspection vehicles or robotic arms that is used by a remote inspection technique. The vehicles and robotic arms allow for collecting digital data to support an assessment of the structure's condition and to identify anomalies. The photos, videos, light detection and range data and other NDE data might all be included in it. The different RITs such as magnetic wheeled crawlers, remotely operated vehicles, and micro-aerial vehicles or drones are touted to revolutionize ship inspection and maintenance with little user involvement. Manufacturers are usually focused on the deploying semi-autonomous RITs for hull cleaning and enclosed space inspection. Such a deployment is likely to enhance surveyors' and owners' employees' safety and to reduce the carbon footprint associated with the reduction in fuel consumption. Moving forward, a remote operated vehicle such as a robotic crawler UAV or ROV that is frequently fitted with connection tools and a remote camera, a platform and control station for the RIV's operation and visual data presentation. A remotely controlled vehicle can operate in the air, sea or on structures is the remote inspection vehicle, which is shortly written as RIV. Trust ecosystem is very important. The trust in robotic technologies is viewed as a complex and multi-layered research topic, especially in the context of its conceptualism manifestation as well as trust dynamics and trust calibration. The trust in RITs relate to a complex interplay among specific work tasks, technological solutions, stakeholder needs, regulations, and policies. A thorough understanding of the trust ecosystem is a prerequisite to the successful integration of the RITs into the current manual-driven human presence dominated hull survey and inspection. The RITs are usually based on what is perceived as a human autonomy teaming, where two parties, that is, human and autonomous digital agents, work interdependently towards a common goal. During a remote inspection process, the expectation is that the operator and the semi-autonomous system will actively cooperate to perform the survey of the vessel. There are two objectives. The first one is ensuring safety in accordance with the International Safety Management Code and international relevant conventions. And second one is widening public acceptance of the vessels that are unmanned. For optimal performance of a human automation system, human trust in automation should be well calibrated. Both disuse and misuse of the automation has resulted from improper calibration of trust, which has also led to many accidents. Additionally, because humans and machines are interdependent, RITs require a level of trust that is carefully regulated in order to prevent the distrust and excessive trust. To clarify the role of trust, the human-machine interaction is distinguished into two general types, which are performance-based interaction and social-based interactions. In the performance-based interactions, the focus is on the human influencing, controlling the robot so it can perform useful tasks for the human. And in the social-based interaction, the focus is on how the robot's behavior influences the human's belief and behavior. In each of these situations, the trustee is the robot and truster is a human. For example, there is a specific job with a distinct performance goal in performance-based interactions. When a person and a robot work together to assemble a product, it is an example of a performance-based interaction. Another example is when a UAV performs surveillance and victim identification during a search and rescue mission. Here, accuracy and turnaround time for the work might be used as performance indicators. In contrast, the performance objective in social interactions is less clearly stated. The capacity of a robot to persuade a person to divulge sensitive information, or the way a robot can persuade a human to take medication or engage in healthy environment are examples of such a job. Moving forward, these are the open questions which we will be able to find the answers of these while presenting the information on this article. The questions are: which psychological insights need to be considered when reflecting on trust in RITs? And the another one is: what aspects make RITs trustworthy for ship hull inspection? And thank you. The next slide will be presented by our next team member.
Second part is pros. So basically, we have roboethics as emerging discipline, basically ethical issue in regard to robots and their impacts on our society are subject of roboethics, research in roboethics and decision discussion about roboethics are currently being promoted globally by several organizations as well as online and open source maker communities dedicated to robotics development. Roboethics has mainly addressed the human ethics of robot designers, manufacturers, and users. However, machine ethics indicates ethics related to forms and codes of conduct implemented in the AI of robots. The aim of this research field is to guarantee that autonomous robots will exhibit ethically acceptable behavior during their interaction with human beings. Another one is AMOR and passive tools. According to the instrumental perspective, robots are mere extensions of human capabilities and can be used as tools as in any situation. Robot can also be part of larger systems that have control over its actions, while robots are viewed as tools that humans use to perform hazardous or dull tasks basically. Ethical impact makers in our society. So smart robots can be seen as impact makers. This view holds that robots can be ethical impact agents that influence the social norms and values. For example, the spread of smart robots, smart special robots, could alter the structure of societies globally, influencing humanity and our relationship with technologies. At the end, so first of all, we have cons. The cons are biasness in decision systems, basically automated AI decision support systems and predictive analytics operate and produce results on the basis of prediction called outputs. Since prediction is easier, it will also become a cheaper commodity. One use of prediction is in predictive policing, which many fear might lead to an erosion of public liberties because it can take away power from people whose behavior is predictive. Other one is artificial moral agents. That is discussion about artificial ethics and ethics challenges. Number of common notions in ethics, and it can be very useful to understand these in abstraction from human case. Other one is the very important one, existential risk from super intelligence. So basically, thinking about super intelligence in long term raises the question whether super intelligence may lead to the extinction of human species. The super intelligent systems may well have preferences that conflict with the existence of human on Earth and may thus decide to end the existence of humans and give theirs and given the super intelligence, they will have power to do so because they do not really care. They have no feelings. They will just kill all humans and remove from the face of the earth. The conclusion is that robotics, by specifying how smart robots are, as kind of a new robotic species that has been increasingly adopted by users at all levels of society. It may serve to affect our ethical outlook regarding both robots and robotics. The framework contributes to extant literature on robotics by identifying two dimensions underlying the fourth perspective.
Hi, so my topic is legal and ethical considerations, challenges in remote family inspection. First of all, human agency and oversight systems should not undermine human autonomy and should support individuals in effective decision making. Systems should help humans in making effective decisions. It should be able to make a right decision. As then there's technical robustness and safety. Preventive approach to risks should be taken that will minimize unintentional harm. So there could be different types of harms like intentional and unintentional. Data should be encrypted in a way that it should be always safe and it should be reliable as it needs to be always. As then this validating and testing. So there should be like human likability in experience, cognition, and emotions. So system should be made like it should work according to the humans, not according to the humans, but even better than the humans. So second-hand information of trusters, including experience of later industries and companies, contribute to the formation of initial trust. So in the fall injection, robot-related features are highly pertinent to well-calibrated trust. So robots are not kind of things that can like have one instruction and they do other things. So they are really reliable in these terms. And for the lawful dimensions, AI should comply with all the legal, national, and international instruments. For example, if a application is in Europe, it should comply with all the Europe laws. And moving to the next slide, there are some non-technical challenges indeed. So first of all, like lack of consumer trust. Past experience has shown that uh, networks are sometimes poor, video quality cannot be always great. We have seen that everywhere. As then this, there are like other environmental conditions like windy areas. In those types of conditions, UAV and unmanned vehicles can have issues like drones. They cannot work really well in the really windy areas. And this is like if vehicle which is autonomous going in the overpopulated area, it can create an issue for other people as well. Social challenges like there could be a prediction issue for the humans. Um, there can be like uh, other situations as well, like light, shadows. These things can create an issue for the technical devices or robots to perform effectively and do what they're supposed to do. So these can create an issue. I think this ethical and moral consequences are a huge challenge when right of way exercised in a strange such as hacks identified by the airborne or underwater enemies should be compared to the traditional counterparts. Moving to the last slide, policy changes and recommendations. policy would be challenged and changed significantly due to removal of human driver from the equation. So it is for sure that like policies are gonna be changed. Things are going to be in the considerations which are not right now. Data regulation policies would have to be determined as to what level of sharing is possible. So in the robots, what kind of information can be shared, what type of information can be restricted to the humans only, because machine hacking issue and policy changes, data integrity, everything needs to be in the consideration. Limited and controlled autonomous vehicle inspection for the safety and security. These are for the security purposes, like have giving the limited access to the robots. And there are some policies like codes of conduct, IACS rules and procedures, standardization of ISO standards, or the IEP 7000 standard series for the real-time remote technology.
So going towards my slide of evaluation of emerging technologies based on the course material. With the beginning of artificial intelligence and robotization, data extracted from the sources, that is, the robots or drone, were becoming null, which made things more difficult in the ship hull inspections. Moreover, now vehicle owners had a preventative approach to mitigate the risks and unintentional harm, as in the systems and the data could be protected from getting hacked, as this could make things more risky. Going forward towards the algorithm and decision making for those robots should be coded in a way that human beings could easily understand the things and can act certain decisions on it. Also, for the artificial intelligence systems and the supply chain comes the responsibility of ecological balance and sustainability by their institutions, as democracy, society, and algorithms are to be considered a valuation part for the design of the processes. Going towards my next slide. Considering the pie chart, and at this point of the time for the current situation, the artificial intelligence and the robotized vehicles are way ahead of their time and are to be considered in the enterprises such as remote inspections. The human works and manual inspections will be ultimately get eliminated. Although there are some drawbacks for the glitches in inspections, imperfection, as still some of the regions which humans can cover are untouched by the remote inspection vehicles and are to be considered in the future models. Emphasizes once more the focal point of the legitimate structure needs to be moved away from the distinction party, driver, or human to blame. So many organizations are coming into the role for the same, and this is giving a boost to the robotization vehicles industry and giving a wider view in the application field as more are growing for experiments and application. Since the vehicle will be processed by organizations and individuals will be simply the travelers, considering them responsible for the accidents will have neither rhyme nor any reason. Going towards my next slide. New protection model to handle the cutting edge model. So an increase in the autonomous vehicles will help the group of protection against human injuries. However, at present, there is no shortcoming protection framework, as in this regulation would bar everyone in the suits related with the individual injury where autonomous vehicles is involved. Like the ongoing framework for such conditions as mishaps, a portion can be funded from government, as this is in total a project which can help the overall growth of the nation with the safety from disaster management and the human life savings, etc. The flow chart on the right hand side shows the technical safety and reliability, and there are steps towards the data governance for accuracy, reliability, and cybersecurity for data protection. And going forward towards the regulation policies such as code of conduct, certifications, etc. The human elements such as skill training, vehicle vessel life, which is to be remotely inspected by the AI vehicles, and there are environmental conditions such as wind, water. They are to be considered a key role in all the circumstances. In short, the future of autonomous vehicle, considering the regulations and policies, would make a major contribution towards the safety and livelihood of not only for the human beings but for the environment as well, as this plays an equivalent role for the emerging technologies. The next person, please.
Hi, my topic is analysis of the legal and ethical consideration. Trust. The trust years of psychological study have revealed that trust is a complicated, convoluted concept. Human robot teams in which humans and autonomous agents work together interdependently to achieve shared goals are replacing human only teams in work processes because to RITs. RITs is basically a remote inspection technology, human robot teams in which people and autonomous agents collaborate together to accomplish common goals and are replacing human only teams in work processes. Effective teamwork dependent on trust in both traditional human teams and teams made up of humans and machines. So to achieve the goal, the trust is essential part because if we have trust on each other, then we can work together as a team so can achieve the good result or goal. The next is work task. The region of reliance between the organizational, technological, and human subsystem is defined by the work task. Human can manage the multiple qualitative tasks in the similar human robot team and may trust on human or robot teams. Duties involved in this task like monitoring and information gathering, decision making or action implementation. Technology task. It is the strongest impact on the trust which shows the performance. Early robot implementation issue in particular undermine trust. The next is ergonomics and quality. So the ergonomics is made to ensure the quality of the robots or quality of the product that robot will be involved. Like the productivity of the robot to producing the items retain the same quality or improve it. So the productivity is considered in this stage that the number of unit produced per unit and total amount per shift a year will be good. The programming. The programming is the main tool to design the robot or software to determine the robot's movement. Like it involved like force, strength, repetition, and reaches of the robot. It includes the security measure to determine whether the task like type of risk will be collaborating in a close manner with humans. So the programming tool is basically used to determine the robot's movement like force, strength, repetition and reaches like many other movements. Technical robustness is since RITs should be dependable and capable of performing to the best of the ability when necessary. So the reproducibility of the outcomes where the system should yield consistent uh, result if the procedure is repeated is also essential. Next is global positioning system. Global positioning system is basically used to localization the position of the robot, but it's not a trustworthy and obstacle remover. So the simultaneous localization and mapping system is used that use the multiple sensor which help to avoid the obstacles. But the GPS globalization positioning system is not unable to find the location underwater. So we use the technology like the underwater location system to localize the or find the position under the water. The next is data management. One of the most important aspects that determines if a RIT can be trusted is the quality of the data, especially the video and the image content. So the data is shared on the connection like Wi-Fi. So we have to share the data very carefully on the internet on the net. So it is essential to have a safe platform for data sharing, storage, and communication among the various stakeholders. So these are the 5 references taken for the article, and it was a good learning article. Thank you.